Implicit and parametric differentiation. Implicit function. Function defined for differentiation of functions containing the variables which cannot be easily expressed in the form of y equals to f of x. Parametric functions are functions involve the use of a third variable t to rewrite a single function y equals to f of x into two separate equations in terms of t, x sub t and y sub t. Example: differentiate square root of x plus square root of y equals to a. So you have that 1 dy over dx. Can write this one as x to the power 1/2 plus y to the power 1/2 equals to a to the power 1/2. So you have this one 1/2 x minus 1/2 dx all over dx plus 1/2 y minus 1/2 dy over dx equals to 0. So dy over dx equals to minus 1/2 x to the power minus 1/2 divided by 1/2 y minus 1/2 or equals to minus y to the power 1/2 over x to the power 1/2 or equals to minus square root of y over square root of x. So find y prime. 0.68 of x squared plus y squared equals to 24. So you have that 2x dx all over dx plus 2y times dy over dx equals to 0. So 2y dy over dx equals to minus 2x dx all over dx dy over dx equals to minus 2x over 2y, or this one dy over dx equals to minus x over y, or it is equals to minus 6 all over 8, equivalent to minus 3/4. To find the equations of a tangent and normal to the curve x squared plus y squared equal to 25 at a point 3,4. So this one 2x dx all over dx plus 2y dy over dx equals 0. dy over dx equals to minus x over y, or dy over dx equals to minus x over y. So equation of tangent line. So tangent line equals to y minus y sub 1 equals to mx minus x sub 1 at point 3, 4. dy over dx equals to minus 3/4 y minus 4 equals to minus 3/4 x minus 3 y minus 3/4, so 4y minus 16 minus 16 equals to minus 3x plus 9. So we have this 3x plus 4y equals to 25. For normal line, m is equals to minus 4/3. So y minus 4 equals to 4/3 times x minus 3. For simplifying this one, 3y minus 4x equals to 0. Find dy over dx from parametric equations. X equals to t minus 1 and y equals to t squared plus 1. So your solution, so dx over dt equals to 1 and dy over dt equals to 2t. So dy over dx equals to dy over dt divided by dx over dt. This equals to 2t 1 over 1 divided by number 1, so equals to 2 times t. Find dy over dx from parametric equations. X equals to t squared and y equals to t cube minus 2. So find the y over the x. Find also the y double prime. So y double prime or d squared y over dx squared. Solution, letter A. For y prime. So dx over dt, dx over dt equals to 2t. So dy over dt equals to 3t squared. So dy over dt over dx over dt equals to dy over dx equals to 3t squared over 2t, equivalent to 3t all over 2. So for B, y double prime or we have that one, d squared y over dx squared equals to d over dt of dy over dx, then dt over dx. Equivalent to d over dt times dy over dx times dt over dx equals to d squared y over dx squared. This was equals to 3/2 times 1 over 2t all over, or equivalent to 3 all over